Welcome to the new online version of Honors 102. My name is Dr. James Harrington. I teach in the philosophy department. You've seen me sitting up in front and messing about with the electronics over the course of the semester, but this is the first lecture I'm going to be giving this semester. Today, we are going to begin to talk about Charles Darwin's The Origin of Species. I want to begin by making a point, a contentious point, but one I would be prepared to defend. The modern project is not a political project, although politics matters. And it's not a literary project, although literature matters. It is a scientific project. Modern science, the product of the scientific revolution, is synonymous with modernity. And yet, we have really gotten to the middle of the 1800s without yet talking about a scientist. Today we're going to change that. Because today we're going to discuss the most important scientist of the 1800s, Charles Darwin. On your screen, you see a picture of Darwin as an old man. This is a very famous portrait, along with a portrait of the co-discoverer of the principle of natural selection, Alfred Russel Wallace. These two men, with their allies, radically changed the way everyone sees the natural world. And today we're going to see how Darwin manages to do that. I'd like to begin by talking about some things I'm not going to do this week. I'm not going to be interested in the general defense of what's called the modern neo-Darwinian synthesis, what we would today know as the theory of evolution as you learn it in biology classes. That theory is not Darwin's theory, although it evolves from Darwin's theory. I'll say a bit in the very last lecture about how we get from Darwin to the world that you learn about in contemporary biology classes. However, what I do hope to do is to convince you that Theodosius Dobzhansky, if you don't know who Dobzhansky is, all you bio majors can blame him for the fruit flies. He's the fruit fly guy and one of the three men most responsible for the consolidation of the modern evolutionary synthesis. Dobzhansky famously said in 1973 that nothing in biology makes sense except in the light of evolution. I'm actually going to turn that on its head a bit this week from what Dobzhansky meant, because what Darwin is doing is showing us precisely that it's the fact that evolution allows us to make sense of biology, which gives us a good reason to accept it. That's the argument of the book that you have in front of you. Now, our other topic that we're not going to spend much time on is the question of evolution versus creation. There are interesting issues in the vicinity of the intersection of religious belief and evolutionary theory. Unfortunately, those interesting questions are not what most people have in mind when they talk about the clash between evolution and religious belief. Usually that comes down to something like the so-called intelligent design debates, the attempt by various creationists to prove that the natural living world must be the product of some form of interventionist intelligence. And the simple fact is we don't have any reason to take those claims seriously. Sorry. We'll talk about some of the issues in the vicinity that are worth taking seriously, again, at the end of these lectures. What is our topic? Our topic is a book. Our topic is a particular book, The Origin of Species by Charles Darwin. And to read The Origin of Species, it's necessary to understand what Darwin is doing. Okay? And as he himself tells us at many points in the book, but most famously at the beginning of the last chapter, chapter 15, which is entitled Recapitulation and Conclusions. He says, as this whole volume is one long argument, it may be convenient to the reader to have the leading facts and inferences briefly recapitulated. Okay, so he's making an argument, right? He's mustering scientific evidence for some kind of scientific claim. Well, what is it that he is arguing for? Well, that's one of the things you need to read for. As you continue to read through The Origin of Species, always be looking for the places where Darwin is drawing conclusions. What is he trying to accomplish here? To do that, you need to look for Darwin's own subdivisions. Again, let's just look at chapter 15. At the beginning of the chapter, he gives a list of subtitles, subdivisions of that chapter. Those are often where he states his conclusions. So look for them, and they're repeated in many of the chapters as the title on the right-hand page of your book. But let me just say a bit about the big picture, right? What is this argument that he refers to? It's really an argument for two distinct claims, although Darwin does not always clearly distinguish them. It's an argument for evolution proper, what Darwin will pretty consistently call common descent, that all of the living things on Earth are descended from one or a few original living things. Darwin's a little careful. He always says one or a few. He doesn't have the evidence that we have that one is the right answer. The evidence that we have comes from molecular genetics. And so he's willing to grant, for example, that perhaps flowers, plants, and animals arise independently. Again, we know that that's not true because all living things on Earth use exactly the same genetic code. And there's no reason for that there are multiple, basically chemically or physically equivalent codes that could be used, and we don't have any reason to see why one rather than another should be preferred. So we can say one. Darwin always says one or a few. And then the second claim, right, and the more controversial claim, the one that even some people who saw themselves as Darwin's allies had problems with, is the claim that natural selection is the mechanism of evolution. It's the mechanism that takes us from this one or a few primitive forms to the complex forms that we find around us today. Now, to understand how Darwin's argument works, right, an argument always starts from somewhere and goes somewhere. Where is he starting? That's what we're going to pick up with in the next two lectures. The next lecture, number 2, will be on the scientific background, and number 3 will be on Darwin's personal background. For today, however, I just want to quickly sketch these big conclusions, these big themes in Darwin's book, so that you know what to look for as you go forward. Now, one of these themes I've already mentioned, right? This combined double argument for common descent via evolution by natural selection. It's worth keeping in mind that Darwin is actually doing another thing as well. He's basically inventing biology as we recognize it today. The term had been used a generation earlier, but what we really recognize of biology as a single unified science of all living things, whether human, animal, plant, in nature, right? This is really coming from Darwin. And if you don't understand that this is part of what he's up to, it's hard to see how the book works. Because otherwise, for example, what's the point of the pigeon stuff? Right? Why does he spend so much time arguing that wild pigeons and domestic pigeons are related to each other? Precisely so that he can show that I can study domestic animals to learn about wild animals. That it's all one unified sphere. And so he's bringing together 3 different disciplines, right? I mean, literally these would have been taught in different schools by different people in different departments in Darwin's own day, right? There's what was then called anatomy and physiology. That's medicine. It was only taught in medical schools. There's descriptive natural history. This is Darwin's own specialty, right? Of going out, collecting samples, figuring out what looks like what, figuring out, right? It roughly combines what we would today consider zoology, botany, and ecology. But that's not really right. Nothing that we do today looks like what was done before Darwin because of Darwin. But he then invokes, right? What he's doing then is he brings to bear on this material, essentially, Descartes. What's the one or a couple of clear and distinct principles, ideas, that can be used to make sense of this entire structure of the living world? And maybe the most interesting thing that he brings to bear is his knowledge of animal husbandry. Right? He invokes the knowledge not of people who are in universities or medical schools, but of pigeon fanciers, sheep keepers, farmers, and says we can learn how biology works, how life works, by talking and taking seriously the knowledge, the craft knowledge, as it's sometimes called, of these people. Now, he's inventing something really new out of a bunch of different kinds of knowledge that he's inheriting. So that's one theme. The other is this move towards evolution. To see that, we need to see what did the world, the natural world, look like before Darwin. So I'm just going to pick a date. It's a nice round number, 1800. And imagine that we're looking at a zebra in 1800. And what do we see? Well, we see something that is pretty closely related to a horse and to a donkey, right? This is the family Equus. And crucially, that fact that the zebra, the horse, and the donkey are all members of the same family is not an accident. It's not a matter of similarity. It explains things about the zebra. So if I ask, right, why does the zebra not have split hooves? The answer is because the zebra is a kind of equus, right? Because it is built on the same model as horses and donkeys. And that's the end of the story. That's the answer to the question, why does the zebra have this feature? And that's true throughout. So the model here, the idea is that the types are more basic than the particulars. The kinds or the forms of things are really what we're doing, what we're interested in, what are real. In a sense, right, the form of a zebra, the perfect ideal form, the thing that makes zebras zebras, is more real than all of the individual particular living zebras that we find. The goal is to see through the individual zebras to the type zebra. And we realize, of course, that this is a complicated structure. So, equus are mammals. Mammals are animals. And the class of animals is more complicated still, of course. Right? Can be divided into vertebrates and invertebrates. And continue to be subdivided in various ways. And all of these are taken to be sort of real facts in the world, right? The difference between mammals and birds, aves, is part of the structure of the world. It's as big and basic a difference in the world as we would say, for example, between chemical elements or between fundamental particles in modern physics, between electrons and protons. It's part of the very nature and structure of reality. And the goal of the biologist, of the natural historian, is to figure out where these joints are, where are the gaps, where are the places where these differences occur. And what Darwin, following on other people, he's not the first to think of this, but he's the most influential to think of this, says, that's not what's going on here. There aren't hard lines between different kinds of animals. They're all descended from the same thing. All right? That if you pick any two animals on Earth, if you were able to create a pure genealogy, that is, find every ancestor going back far enough, you would eventually come to a point where every pair of animals that lives on Earth, between any pair of living things, right? Between me and the oak tree outside my window, if we could trace our ancestors back far enough, I have a shared ancestor with that oak tree. The oak tree is not a fundamentally different kind of thing than I am. The difference between me and the oak tree is just a difference of degree, not of kind. There's no more fundamental nature of difference between me and the oak tree than there is between me and my sister. So over the rest of the week, that's what I'm going to do. I'm going to sketch how does Darwin get there? What are the reasons he has for making this massive change? Now, I'm going to divide what it would normally, in a normal semester, be 3 50-minute lectures into a series of shorter lectures of between 10 and 20 minutes apiece. So the next two, which are the continuation of the lecture that I would normally give on day one, are on the scientific background to the origin of species. What did the science look like when Darwin learned it, say, in school? And also, what is his background, his biography, and most importantly, the story of his famous voyage around the world on the Beagle? We'll then have two lectures on the actual scientific content of the origin of species, and then 3 lectures on the reception of the book and of the theory. Darwin's life and controversies following the publication of The Origin of Species, the reception of The Origin of Species in the scientific community, and then a brief discussion of the flame wars around The Origin of Species that really don't start until much later in the 1800s. It's worth noting these flame wars are really more of a 20th century phenomenon than a 19th century phenomenon. So that's what I have to get us started. Can either take a break or jump right into the next lecture on the scientific background to the origin of species.